So a very good afternoon to all the respected academicians, my fellow presenters, and all the worthy members of the committee. My name is Engineer Imran Arshad, and I am a PhD student in a Department of Irrigation and Drainage Engineering, Faculty of Agriculture Engineering, Sindh Agriculture University, Tandojam, Pakistan. The co-authors of my studies are Dr. Irfan Ahmed Sheikh, Dr. Shakil Hussain Chattha, and Engineer Zahir Ahmed Khan. I would like to welcome you all to my presentation having a title, Effect of Length of Cutoff Wall on the Seepage Characteristic of a Non-Homogeneous Earth Dam using Finite Element-based software, Geo-Slope. This is the presentation outline for my work. Now, starting with the introduction, actually, what is a dam? The dam is an impermeable barrier in front of the water flow that is mainly used to store or divert the flow of direction. Dams may fail due to some criteria such as piping, overtopping, and seepage. What is seepage? Seepage is it is a flow of water through pores or porous media due to potential head difference. Seepage occurs in all types of dams, even in RCC gravity dams. Now the questions come, why there is a seepage through a dam? Due to potential head difference, there is always occurs a seepage through the body of the dam and its foundation. Now, what will be the adverse effect of seepage on the safety of dam? Uncontrolled seepage through the body of the dam may lead to internal erosion and consequently its failure. It may cause sloughing of downstream slope failure. Seepage may lead to piping failure of the dam. Now, how we can control it? The cutoff wall and filter, it is an efficient way for seepage controlling through a dam foundation. Cutoff wall with various thickness and depths were suggested as another alternative for seepage remediation. Installation of cutoff wall or sheet pile can use to control the reduction of the exit gradient and seepage flux. Now, there are several methods to analyze seepage, in which some of them are analytical, experimental, and finite element analysis. So in our work, we have work on a Geo-Slope software, which is a finite element-based software. So let us discuss something about finite element. Finite element analysis is a computational scheme in which the domain of interest is discretized into a smaller elements by imaginary nodal points, and field variables of the interest are simulated and analyzed over the whole domain of interest under different scenarios with the detailed and precise solutions. Here are some of the examples for finite element analysis. Now, Geo-Slope software, this is the software which we have used in our study. It is developed in 2003 and it is capable to analyze groundwater seepage and excess pore water pressure dissipation problems. This is the Governor General equation which is used by the CFW software to compute the results. The objectives of our study is to analyze the seepage flow, exit gradient, and maximum seepage velocity through the body and the foundation of the non-homogeneous earth dam at various reservoir levels for three different cases, that is the original design, dam with a partial cutoff wall, and dam with full cutoff wall. This is the location of Hub Dam. It is located 35 kilometers away from Karachi at Hub River. These are some of the salient features of Hub Dam. This is the flowchart which describes the stepping of that, how we have created the model. Initially, by using Geo-Slope software, the geometric models were created and steady state analysis was selected to simulate the hydraulic condition beneath the dam foundation. After that, the material was first created and calibrated using trial and error method and then applied to different regions. The ups and downstream slope boundary conditions are assigned as Dirichlet's and Newman boundary nodes. The nodes at the bottom of the foundation of the dam are considered at zero flux. Finally, by using the solve manager, the mesh was verified, analyzed, and solved for computation. And finally, the simulated result has been obtained by as an output. This is the cross section of the hub dam on which we have studied in our research work. This is the mesh formation which is generated by using Geo-Slope. Here are three cases. This one is for the original design, the second one is for the partial cutoff wall, and the third one is for the dam having a full cutoff wall. These are the hydraulic conductivity and geological parameters which we have provided to the model. And these are the hydraulic conductivities which we have obtained through a trial and error method. These are the simulated results. This is the result for the case 1. This is for the result when the reservoir height was at 270 feet. And likewise, this is at the 339 feet and 346. Here we can see the flow net and the equipotential lines and phreatic line. This slide shows another view of case 1, that we can see that from the upstream slope, the phreatic line is passing through the shell, and while it is going to the downstream, it is falling into the filter drain. So there will be no any cutting of the downstream slope, so which means that the dam is safe against piping. Likewise, these are the simulated results for case 2. These are the results for case 2 for the phreatic line behavior. And this is the result for case 3 when the dam is with the full cutoff wall. Here we can see the equipotential line and flow net didn't develop because of there was no base flow. All the flow was through the shell only. These are the overall results which we have obtained for seepage flux, exit gradient, and maximum seepage velocity. This is the graphical relationship for seepage flux, as likewise for exit gradient and for maximum seepage velocity. Now I will conclude my presentation. The phreatic line pattern follows standard design for each case, which entails that the dam safety is not endangered from the seepage point of view. The exit gradient value is within a permissible limit for each case, that is less than unity. Estimated seepage flux is minimum and maximum seepage velocity is within safe limits. The imperviousness of the foundation material is predominant over shell material. Therefore, the use of partial cutoff wall and full cutoff wall may not contribute much to lower down the various flow parameters respectively. The numerical model give a deep understanding for a hydraulic and geotechnical problem. Hence, it can be concluded that hub dam perform effectively since its construction at its original shape and design. These are the references used in our study.